Tyrannosaurus rex wasn't the most dangerous predator to ever walk the earth. That throne actually belongs to creatures you've probably never heard of, and understanding why changes everything we thought we knew about prehistoric dominance. For decades, T-Rex has dominated our imaginations as the ultimate killing machine. Museums build entire exhibits around it. Movies cast it as the unstoppable monster. But here's what paleontologists have quietly known for years. Several predators possessed advantages that made them far more lethal than the famous tyrant king. Some were larger, others were faster. A few hunted in ways that would have left T-Rex completely defenseless. The story starts in North Africa, roughly 100 million years ago, where rivers carved through a landscape nothing like today's Sahara Desert. Back then, this region resembled the Florida Everglades on an almost unimaginable scale. Massive waterways stretched for hundreds of miles, creating an environment where one predator evolved capabilities that redefined what it meant to hunt. Spinosaurus wasn't just big, it was enormous, stretching nearly 50 feet from snout to tail and tipping the scales at 44,000 pounds. That's roughly 10 feet longer than the largest T-Rex ever discovered. But size alone doesn't tell the full story of why this creature was so formidable. Picture a crocodile's head mounted on a body built like a theropod dinosaur. Then add the swimming adaptations of an ancient whale. That's Spinosaurus. Its jaws bristled with interlocking teeth, designed specifically for gripping slippery prey. Behind the initial row sat another set of slender, sharp teeth, followed by 12 more deeper inside its mouth. This wasn't a mouth built to crush bone like T-Rex. It was engineered for something else entirely. The legs tell you everything you need to know about how this predator operated. Short, muscular, and paddle-shaped, they resembled the limbs of modern shorebirds far more than typical dinosaur legs. Scientists now believe the feet were webbed, with skin stretched between the toes for propulsion through water. While T-Rex stomped across dry land hunting hadrosaurs, Spinosaurus glided through murky depths, chasing sharks and massive fish. Those powerful forelimbs, tipped with curved claws, could stab deep into struggling prey or tear through flesh with surgical precision. And then there's the sail, that distinctive row of spines extending along its back. Paleontologists still debate its exact purpose, but one thing remains certain. No predator before or since has looked quite like this. But what made Spinosaurus truly dangerous wasn't any single feature. It was the combination of hunting in an environment where T-Rex would have been helpless. Drop a Tyrannosaurus into deep water and you've got a 9-ton animal struggling to stay afloat, unable to use its primary weapons effectively. Spinosaurus owned that territory completely. Now shift your perspective to South America during the mid-Cretaceous period. The landscape here told a different story, one of vast plains and dense forests where herbivorous dinosaurs grew to staggering sizes. This ecosystem needed a predator capable of taking down prey that dwarfed anything in North America. Enter Giganotosaurus, the southern giant. Despite what popular culture tells us, T-Rex wasn't the largest carnivorous dinosaur in history. That distinction belongs to this South American monster, which could weigh up to 30,400 pounds and measure 43 feet in length. Its skull alone stretched nearly 6 feet, housing over 76 teeth, each one approximately 8 inches long and sharp as butcher's cleavers. What's fascinating about Giganotosaurus isn't just its size. It's how the creature was built for a completely different hunting strategy than T-Rex. Those relatively long and powerful forearms, equipped with 3 grasping claws, allowed it to hold on to struggling prey. The muscular legs could propel it at speeds around 30 miles per hour. And unlike the ambush tactics favored by many large predators, evidence suggests Giganotosaurus may have hunted in coordinated groups. Think about what that means. T-Rex relied on overwhelming bite force and solitary ambush attacks. Giganotosaurus potentially used pack tactics against prey that could exceed 100 feet in length. These weren't just different predators. They represented entirely different evolutionary solutions to the same problem: how to kill and eat the largest animals that ever walked on land. The herbivorous dinosaurs of South America grew so massive partly because predators like Giganotosaurus pushed them toward gigantism as a defense. It became an evolutionary arms race where prey got bigger to survive, which in turn selected for larger, more coordinated predators. This feedback loop created an ecosystem unlike anything in the northern hemisphere. Researchers estimate Giganotosaurus could live over 50 years, taking 30 to 40 years to reach full maturity. The juveniles were vulnerable, exposed to other predators and environmental dangers. But once fully grown, they had virtually no natural enemies. An adult Giganotosaurus represented the apex of its food chain in a way that few predators ever achieve. What makes these discoveries so compelling isn't that T-Rex was weak or overrated. It's that prehistoric Earth was far more diverse and complex than we ever imagined. Different continents, different time periods, different environmental pressures. All of these factors shaped predators with wildly different capabilities. And we've only scratched the surface. Because while Spinosaurus dominated the waterways and Giganotosaurus ruled the southern plains, other predators were evolving specializations that made them lethal in ways that had nothing to do with size or strength. Speed wasn't just about running fast. It represented a completely different survival strategy, one that smaller predators had perfected millions of years before the giants emerged. Consider Carnotaurus, the meat-eating bull that prowled ancient South America 70 million years ago. This creature measured roughly 26 to 30 feet long, stood over 10 feet tall, but possessed the build of a sprinter rather than a heavyweight boxer. Those distinctive horns above its eyes weren't just for intimidation. Scientists believe males used them in brutal headbutting contests, ramming and pushing to establish dominance over territory and mates. But here's what made Carnotaurus genuinely remarkable. Its vision-based hunting system operated on principles fundamentally different from T-Rex's smell-dependent approach. Carnotaurus had an exceptionally wide field of view, capable of detecting the slightest movement across vast distances. A herbivore shifting position in distant bushes wouldn't escape notice. The predator's large eyes and short snout created a facial structure optimized for tracking prey visually rather than following scent trails. Those incredibly tiny forelimbs, even shorter than T-Rex's arms, seemed useless at first glance. Yet the shoulder joints possessed extraordinary strength, functioning like stabilizers during high-speed pursuits. When Carnotaurus reached speeds of 30 to 37 miles per hour, those shoulders prevented the body from pitching forward, maintaining perfect balance through rapid turns and sudden stops. The teeth tell another story entirely. Small, jagged. Not designed for crushing bone like T-Rex, but perfectly suited for ripping through soft tissue at tremendous velocity. This predator didn't need bone-crushing force. It relied on speed, precision, and the element of surprise. Now travel back even further, to the early Jurassic period between 183 and 190 million years ago. The world, then, was barely recognizing what carnivorous dinosaurs could become. And standing at the threshold of this evolutionary explosion was Dilophosaurus, the two-crested lizard. Hollywood got this one spectacularly wrong. The movies portrayed a small creature with a neck frill that spat blinding venom. Reality delivered something far more impressive. Dilophosaurus grew up to 23 feet long, stood nearly 10 feet tall, and weighed around 880 pounds. Roughly the size of an adult brown bear, but with capabilities no bear could match. Those distinctive twin crests sparked decades of scientific debate. Early researchers thought they regulated body temperature or served as weapons. Later analysis revealed the crests were made from thin, fragile bone, far too delicate for combat. The current consensus suggests they functioned as display structures, similar to how modern peacocks use their tail feathers to attract mates or establish social hierarchy. What's fascinating is how long scientists doubted Dilophosaurus's hunting prowess. Some argued its jaws were too weak for taking down large prey, suggesting it scavenged carcasses instead. Then fossil evidence emerged showing matching tooth marks on the bones of contemporary herbivores like Ceratosaurus. Dilophosaurus wasn't just hunting, it was the apex predator of its time, the forefather of every famous carnivore that would follow. But perhaps no prehistoric predator has been more misunderstood than Velociraptor. Thanks to popular films, most people imagine a creature standing eye level with an adult human, hunting in coordinated packs, disemboweling prey with massive sickle claws. Strip away the Hollywood exaggeration and you find something equally impressive, just smaller. Real velociraptors stood about waist-high to an adult human, weighed around 100 pounds, roughly the size of a modern wolf. And they were covered in feathers. Those feathers weren't decorative. They served multiple functions, regulating body temperature, possibly assisting with mating displays, and providing insulation in the harsh Gobi Desert climate where they lived 75 million years ago. Velociraptors shared numerous traits with modern birds. Hinged ankles, rotating wrists, a wishbone, forward-facing toes. The connection between birds and dinosaurs isn't metaphorical. It's direct lineage. The intelligence factor deserves attention. Velociraptors' brain-to-body ratio resembled modern birds of prey, enabling advanced visual processing, strategic hunting approaches, and potentially cooperative behavior. That 3-inch sickle-shaped claw on each foot wasn't randomly slashing. Recent analysis suggests velociraptors use those claws with surgical precision, targeting vital areas while maintaining balance through their long, stiff tails. If Velociraptor represented refined efficiency at moderate size, then Utahraptor embodied the terrifying potential of scaling that design upward. An adult Utahraptor could reach 23 feet in length, stand 10 feet tall, and weigh over 1,000 pounds. Imagine a tiger-eagle hybrid with 10-inch sickle claws. Fossil evidence from trackways and bone beds suggests these creatures hunted in coordinated groups, capable of bringing down prey many times their own size. This behavioral pattern was exceptionally rare among carnivorous dinosaurs. Most large predators hunted alone or in loose associations. Utahraptor developed something approaching true pack dynamics. And here's the unsettling part. Scientists have found no evidence of a larger land-based predator sharing Utahraptor's ecosystem during its lifetime. It occupied the absolute peak of its food chain, combining intelligence, weaponry, size, and social coordination into a package that left no viable challengers. These weren't isolated examples. They represented different solutions to the same fundamental challenge: how to kill and eat other animals efficiently enough to survive. Size mattered for some species. Speed defined others. Intelligence, coordination, specialized anatomy. Each path offered advantages and imposed limitations. The prehistoric world wasn't a hierarchy with one ultimate predator at the top. It was a complex web where dominance depended entirely on context, environment, and circumstance. The same factors that made one predator unstoppable in its native habitat could render it helpless somewhere else. That's the real lesson here. Evolution doesn't create perfect killing machines. It creates specialists, each one supremely adapted to specific conditions that might not exist anywhere else on Earth. Understanding these predators forces us to reconsider everything we thought we knew about prehistoric dominance. T-Rex deserves its legendary status, but that status came from being perfectly adapted to one specific time and place. It wasn't the ultimate predator. It was the ultimate predator for late Cretaceous North America. Spinosaurus owned the waterways. Giganotosaurus commanded the southern plains. Carnotaurus perfected speed hunting. Dilophosaurus pioneered the theropod predator blueprint. Velociraptor and Utahraptor demonstrated that intelligence and coordination could rival raw power. Each one represented a different answer to survival, shaped by millions of years of environmental pressure, competition, and adaptation. The prehistoric world didn't have one king. It had many rulers, each reigning over their own domain with capabilities we're only beginning to understand. That's what makes paleontology so compelling. Every new discovery doesn't just add another name to the list. It reveals how much more complex, diverse, and fascinating life on Earth has always been. The monsters were real. They were just far stranger and more varied than any movie could capture.